Welcome to the second installment in our 2022 webinar series. I'm Julia Speaker, Project Manager and Cast It Team Lead in the American Metal Casting Consortium's Innovative Casting Technology Program. Cast It is an acronym for what we do, Casting Advanced Systems Technology Integration Team. Our webinars are funded by the Defense Logistics Agency. So what's new in this 2022 webinar series is the project management by a new awardee that precedes the manufacturing engineering of the casting processes in a legacy casting launch, especially in the context of a cold start new awardee who is a machine shop. Cold start is a nickname for a legacy casting contract for which there is no existing approved casting source, and the casting's mold making tooling may be lost or unavailable. And lost or unavailable includes the machining fixtures. The consequence of cold starts is excessively long lead times suffered by DLA and the weapon systems needing these cast metal replacement parts. 70% of new awardees for DLA legacy cast metal parts are now machine shops. So in part one of this 4-part webinar series, we address the obvious first question a machine shop would ask. Can this casting geometry be duplicated in both geometry and material properties if we were to machine the shape complete from a wrought block or bar of similar metal alloy? In part one, we walked through the initial project management considerations of that choice in terms of machining capabilities, casting process capabilities, the specifications, and the approval or denial process by the engineering support activity. In parts 2 through 4, we acknowledge that the legacy replacement part will remain a casting, and we will walk through the two most powerful metal casting processes for high specification legacy castings. That is, the air-set sand and ceramic shell investment casting processes, and in either mold process case, how to plan for the finishing processes on the as-cast geometry prior to machining a few surfaces to final net shape. Since so much of a casting's final net shape remains as cast, finishing processes on those surfaces is important. Here is a glimpse of highlights of the air-set sand process and its major capabilities. Leading off is our Cast It teammate Mike Gwynn, who is our expert on casting design and manufacturing engineering, with a background in operations and project management. Mike will focus on basics of getting started with a manufacturing plan for the air-set sand process. Following Mike will be Gary Burrow, our Cast It teammate who is a 5th-generation mold cavity tooling builder with expertise in both the air-set sand and the ceramic shell investment processes. Gary is also an expert in additive and subtractive manufacturing technologies and how to apply them to both casting tooling and direct printed mold elements. But first, here's Mike.
Over the years, in DLA's support of weapon systems with spare parts made from castings, there's been quite a change in the difficulty in getting those castings approved and produced. In the earliest days of cast spare parts support, the original weapon system OEMs had in-house machine shops very familiar with working with OEM's original metal caster partners. When approving a finished machine casting, the first article test lab had direct access to the original engineering authority who specified a casting for the weapon system's manufacturer. So the insignificant potential nonconformances involving an as-cast dimension or an as-cast surface condition were readily resolved with the primary engineering source. In more recent years, the new awardee of a legacy casting contract was virtually always a metal caster, but rarely was it the original metal caster that the weapon system OEM chose. The machine shop was a partner with the metal caster awardee, and the two had much more of an obligation to produce the legacy casting exactly in compliance with the drawing than when the original OEM's engineering was involved. However, the basic choice between air-set sand and investment casting processes was established at the bid stage, as one of those two casting processes is what the awardee produced. Since metal casters are very rarely producers in both processes, the choice for air-set sand was made prior to the bid. The metal caster would recognize a casting from the verbiage in the drawing and its dimensional tolerances and other elements in the technical data package. Digging deeper into the drawing notes citing casting-related specification, as cast tolerances and other clues, the metal caster was able to determine that the casting was intended to be produced in a sand mold. because of its tolerance capability, cosmetic appearance advantages, and/or its ability to achieve higher mechanical properties in areas designated as such on the drawing, the sand metal caster would choose the air-set sand process. Now, as bidders are most likely machine shops, the subtleties in the solicitation, especially the drawing, may not be so obvious to a cold start machine shop new awardee. Those subtleties have to be investigated, and that takes time. Once awarded, time becomes one of the essentials in successful completion of the DLA contract, so quickly determining the casting aspects of the manufacturing plan becomes job one. A job one tool has been developed by the American Metal Casting Consortium and its partner, the Non-Ferrous Founders Society. This job one tool can unravel those subtleties in the solicitation language and technical data package not so obvious to a machine shop. The tool is available online, no charge, with fast access to casting-related procurement and specification data, and this new tool is specific to legacy casting procurements. Known as ICON, Integrated Casting Order Network, the website enables a machine shop cold start awardee to immediately gather much of the job one priority information for a quicker, better planned start. Upcoming are a couple of screenshots from ICON illustrating the casting-specific detail that can be gleaned by a cold start machine shop new awardee. But first, here's an overview of how ICON can be effectively used by such an awardee pursuing job one. And as a preface to that overview, the Non-Ferrous Founders Society is actively pursuing machine shops to not only register in ICON, but also to join their metal casting members for broader perspective of the metal casting industry. Among those involved is the Executive Director of the National Tooling and Machining Association, the Association of American Jobbing Machine Shops. The first step for a cold start machine shop awardee for a DLA legacy casting contract is to go to the Non-Ferrous Founders Society website, nffs.org, and click on the ICON link. A machine shop can register in the ICON portal at no charge and establish a business profile that describes the machine shop's capabilities and new business interests. The second benefit of that profile is access via an ICON portal inbox to daily updates of DLA and some other DoD solicitations that have been filtered by the machine shop registrant's profile and preferences. But the immediate first benefit of the Cold Start awardee's registration is access to much of the casting-related Job 1 details of the award just won. In recent procurements or procurement history, and the machine shop's award number, the Cold Start new awardee can extract these important casting-related details from ICON. First, verification that the component is based on a casting. Second, the specific casting alloy and the specific mold process from which the casting has been produced in the past, such as sand casting, investment casting, and permanent mold casting. Next, a list of the component's drawing numbers, quality assurance provisions, etc. Once the award has been made, a new awardee search cannot directly download drawings via C folders, but knowing the numbers enables C folder downloads from DLA's Internet Bid Board System, DIBS. Available to a new awardee registrant is a link to available metal casting tooling and perhaps machining fixtures. Also, prior approved metal casting sources and additional sources who may be capable in the alloy and process required by the component. Here are a couple image grabs from the ICON screens illustrating those capabilities and benefits. First are examples of awarded solicitations showing the casting alloy and molding process. Below that is a list of drawings from one of those awards. Next is a result from a link to search for existing casting tooling. A further click reveals contact information for the supplier who owns the applicable tooling. And finally is a screen showing a number of technical details about the casting embedded in the award. Next in Job 1 is finding and understanding all the specifications that control the requirements of the finished casting. A good start to understanding the specifications is to classify them by the subject, which is generally not decipherable from their name, such as AMS A21180. The Defense Logistics Agency offers a search tool that quickly classifies specification numbers found on a legacy casting drawing. Here and in the chat box is the quick search link. In this image is an example of a quick search query of a casting related specification number. This mill specification classifies as inspection requirements. The specification document still needs to be searched for, downloaded, and studied as part of the Job 1 manufacturing plan, but at least the type of specification is now known. However, commercial specifications that require a download fee, as ASTM and AMS specs often do, are not identified in DLA's quick search, nor are the private specifications of military prime contractors like Boeing or BAE Systems. Web browser searches will usually find those specifications, but obtaining copies may require purchase from the specification body or a rights guard agreement with Boeing, for example. All that said, the power of project management in planning all the manufacturing tasks and timelines will be blunted if all the specification requirements are not found, studied, and planned for at the outset. Well, now I'll pass the baton to Gary Burrow, our Cast-It team partner and expert on all aspects of the AirSet sand process, having applied AirSet to DLA legacy castings successfully several times in the past. So, here's Gary.
Thanks, Mike. In my work as a mold cavity tool builder over 4 generations, H.A. Burrow has produced tooling for almost every metal casting process. Over those years, our largest market segment has been military and aerospace castings. Since the AirSet and sand ceramic investment casting process are so compatible in that segment, I have built tooling for and now use additive manufacturing for those who process over a wide variety of military and aerospace castings. As Mike said, after gleaning as many Job 1 insights as possible from ICON and assuming a prior approved metal casting source is not identified or not willing to partner, the next step is investigate and choose an AirSet foundry partner. In that choice, it is critical to investigate the capabilities of mold cavity tooling builders that a foundry partner candidate would choose. Typically, metal casters partner with tooling builders who have their own separate businesses. As personal communication and CAD data sharing has advanced digitally, metal casters have broadened their tooling relationships from locally to regionally and often nationally. In my case, for example, I am located in Montana, but my partner metal casters are typically on the West Coast or Midwest, and I have partner machine shops. One of them is right here near me in Montana, also some in Wyoming. I won't repeat it here, but a major part of our 2021 webinar part one was how and why the mold cavity tooling builder is the most capable business partner to lead the CAD effort in building the solid model versions for all the tooling. All the tooling includes dimensional checking fixtures, casting straightening fixtures, and the machining fixtures. In the chat box is a URL to take you to that 2021 webinar part 1 video. From the 29-minute video mark through the 40-minute mark, I explain all that the mold cavity tooling builder would do to help partnership with the metal caster and machine shop to assure first article approval and a successful production launch. As in our 2021 webinar part 1, we explained that there are 3 versions: the legacy casting solid model, all built from 2D drawings. First, to replicate the 2D drawing; second, to build the mold cavity tooling and make the casting; and third, to machine the casting. Since the machining fixtures are dependent on the third solid model, it is prudent for the machine shop to collaborate with the mold cavity tooling builder in the design of these machining fixtures. That's basically to establish that the tool points are carried throughout the entire process. If an apparently capable foundry doesn't have an established relationship with the mold cavity tooling builder with those capabilities to lead the CAD effort, then the AirSet Sand Foundry would not be a wise choice. Here is a relatively thin-walled, lightweight aluminum casting designed typically for military aircraft from the 1950s, 60s, and early 70s. With mechanical flight controls, the 2 pulleys are a redundant cable system for controlling a fighter jet's rudder. The ball joint and the lever actuates a nearby cockpit canopy vent via a linkage. The vent is intended to be open on the ground at taxiing speeds. However, the box section on which the ball joint and lever is mounted is designed to withstand impact through the linkage if the vent were to accidentally open in flight. We will use the casting to illustrate some of the high-level tasks of the project. Management means lead timeline that need to be thought through about in evidence and implemented in the manufacturing plan. Manufacturing engineering of the process interface geometry before mold cavity design and construction begins. One of the most powerful capabilities of the air set sand process is to be able to design the geometry that fills the mold. Evacuates air and combustion gases as the mold is filled and enables high solidification integrity. In sand foundry jargon, that geometry is called gating, venting, risering, and chilling, basically the plumbing system. A shorthand term that we use in this process interface geometry, that is engineered geometry added to the mold cavity that does all of that. The reason that process interface geometry is so important in casting production is that mechanical properties achieved in a casting are accomplished with process interface geometry. Here are images of some of the internal thicknesses on a 3D basis that guided the design of the riser locations of gating system to fill the mold cavity. Shapes are machined entirely from a wrought block or part of a similar alloy already have the mechanical properties established in the block. Yes, there are differences in longitudinal and transverse properties depending on the orientation of the block or bar when it was rolled or forged, but as a machine shop, you know what those properties are before you start machining. So the machine shape can be oriented to best use the longitudinal properties of the part's structural strength. Dramatically different from that is the casting process. Any casting has mechanical properties that are local. Those local properties are based on how the temperature and mass gradients of solidification were set up in the process interface geometry design. A very important capability in the process interface geometry design for air set sand casting is to place metal shields in mold cavity walls to increase the solidification rate. When the solidification rate is increased, the microstructure of the metal is finer and the mechanical properties at that specific location are better. Often the chill needs to have a surface that matches a curved or mold wall, and we can call that a form chill. In this image, the drawing calls out designated areas where mechanical properties are higher to address the highest stresses from the load case. Here are shown the local location of chills to enable those local higher solidification integrity mechanical properties. The next image shows the load case for the rudder control pulley cables and the cockpit vent linkage. Here are the stresses that result in showing the reason for the chill locations. Finally, the 3D movie of the temperature gradient shows how the entire system of mold cavity geometry and process interface geometry complements and complies with the specific mechanical properties in general and in the designated areas. Manufacturing engineering of the casting cavity design and construction for dimensional capability. Notice that I said casting cavity design and construction instead of the usual term casting tooling design and construction. Nor did I say the entire mold cavity design and construction. It is the casting cavity, especially where the dimensions are formed, and that's where the capability of additive manufacturing technology can improve dimensional accuracy. Once again, I recommend reviewing 2021 Casted Webinar Part 1, in which we explain all the principles of controlling casting dimensional capabilities when made in sand molds. The reason we addressed dimensions so thoroughly in that webinar is the fact that 80% of all DLA legacy casting first article non-conformances are for dimensional reasons. Without repeating our 2021 Webinar 1 Part 1, here's what the machine shop awardee can learn about air set sand casting dimensional capability by watching it. First, pattern maker's contraction is a guess that I, as a mold cavity designer, make. I have a lot of experience in that guess, but it is still a guess. It also is 3D contraction that doesn't always occur at the rate I choose, or the rate doesn't occur at as I expected in those directions. When contracted doesn't occur as expected, some dimensions won't wind up in the middle of their tolerance band. So statistically, some castings will have dimensions outside their tolerance. That can be a fatal at first article dimensional inspection problem. The second most significant dimensional capability problem in sand casting is mold assembly degrees of freedom. As molds are assembled with separate pieces, those pieces in their tooling have tolerances that stack up. Printing mold elements so that they are just one piece eliminates that stack up variation. Printed mold elements can also eliminate draft where draft is dimensional problem. Manufacturing engineering of quick prototypes before production castings are made, even if only 5 castings are required. The requirements for DLA legacy castings first approval are so stringent that prototypes to check solidification integrity and dimensions are a prudent first manufacturing step. With the advancements in additive manufacturing technologies, either by printed mold elements or by printing entire molds, prototypes can be made from the same solid model as production tooling will be built. Therefore, quick AM prototypes can be expected to be the same as airset sand production castings dimensionally. The surface finish will be a little coarser, but that's not an issue when checking solidification and integrity dimensions. Even if the order of requirement is only 5 castings, making 2 throwaway castings is wise. Don't bother finishing the prototypes or machining them. Just cut off the process interface geometry, media blast them, and grind down any sharp fins. Then send the 2 prototypes to radiology for a quick evaluation of solidification integrity. After that, send the 2 rough casting to dimensional evaluation. Either scan them and compare them to the solid model digitally or use a CMM to check the most important dimensions. Now is the time to find pattern maker's contraction, rate, estimate errors, mold, assembly variations, or others in the solid model. Occasionally, such quick AM prototypes are sufficient in solidification integrity, dimensional correctness, and surface finish, in that the prototypes can be added to the production quantity. If not sufficient for production quantity, little value added has been invested in the prototypes, so just melt them down in the process of pouring new castings. All the corrections made will result in production castings that will be approvable at a first article inspection. These are the elements that I do every day in the development of the 3D solid models, using additive and subtractive manufacturing technologies to build mold tooling or mold cavity elements in collaboration with metal caster and machine shop partners. Several times in the past, I have made DLA legacy castings in airset sand, taking responsibility for the whole project when other metal casters and or machine shops had failed and their contracts canceled. These project management principles deployed at the outset really do work, instead of just start casting, manufacturing, and machine net shape in the usual way.
In summary, for most DLA legacy casting manufacturing, the airset sand process is very capable when most or all of airset sand capability facets are needed. Only when as-cast dimensional tolerances are difficult to achieve does the ceramic shell investment casting process have a significant advantage. Even so, the ability to use additive manufacturing technologies to print entire airset molds or airset mold elements with no draft and more accurate one-piece mold elements makes the need to choose the investment casting process less necessary. And airset sand castings are significantly less expensive than investment castings. In military and aerospace castings with higher designated mechanical properties in some regions of the casting design geometry, the airset sand process is required. The reason is the ability of the airset sand process to easily deploy temperature and mass gradients in the mold as the mold fills to achieve more rapid, more complete solidification where higher mechanical properties are required. The investment casting process uses a hot ceramic-fired mold when poured. So, setting up significant differences in temperature and mass gradients inside the hot mold is minimal at best. On the other hand, in part 3, we will walk through the investment casting process, which needs to be considered in parallel with the air-set sand process in the early project management evaluation of the casting requirements in the technical data package. The dominant capabilities of the investment casting process are 1. Unsurpassed dimensional capability, 2. Unsurpassed surface finish and cosmetic appearance, 3. It's most applicable to low volume requirements, and 4. It has the most directly applicable and complete additive manufacturing options for no tooling. However, there are a few cons. First of all, it is the most expensive metal casting process without regard to the alloy chosen, and it also is less capable of achieving those higher mechanical properties in the designated areas of a casting. So we will announce the date and time of part 3 in an email to you personally. I'll now open up the question box for your questions and comments. Our CAST team is standing by and looking forward to engaging with you personally.
All right, so good morning, everyone. Let me figure out how to, the video is still playing on my end, so let me pause that. All right, so I'm going to ask the CAST team to go ahead and start up their videos as we segue into the Q&A portion. If you so desire, you don't have to start up your video, but I would like to take a moment and introduce the team to everyone. So first off, at least on my screen in the corner, we have Mike Gwynn, who is our casting design expert and also webinar guru. Then we have Dick Tiano, who is an expert in all things 3D data. We also have Dave Powlett, who's the VP of Technology at Steel Founders. Gary Burrow looks like he's joining in too. He is, as you guys heard, the 5th generation pattern maker and super knowledgeable in all things castings. And then we also have Keith Sturgill on the line, who is a metallurgical engineer, and he's an expert in all things DLA and government processes. All right, and then Casey is helping me out with logistics. So we'll go ahead and get started. So feel free to ask any questions in the Q&A box. But for starting off, I have a question for you guys, so I will launch that now. All right, so you guys should see a question popped up. So for a machine shop cold start legacy casting awardee, what would be an important consideration in the choice of a metal casting partner? So if you guys want to go through and select which ones you believe to be important, I think we'll start off with that. So I'll give everyone a minute. All right, so I'll say there are no wrong answers. So if you do not know the right answer, we are going to talk about this, but please feel free to pick a choice or pick 2 choices and we'll talk about them.
Are we to do just the first one? I see that there, you can hit the next button and find another one, Julia.
Yeah, I say let's just talk about the first one for now. I tried to do it where I only launched one, but I guess that didn't work quite as well as I anticipated.
No, it works fine.
All right. So, Mike, it looks like maybe people are a little stuck. Do you want to go through this first question and maybe explain why the answers are what they are? So I'll go
Sure.
ahead and end the
Yeah.
poll, and I think that'll show up as the answer.
Yeah, so if you're a cold start machine shop and you don't have a partner and there's no partner available, what would be some things that you really should do in choosing a partner that would be a brand new partner, obviously, since this is a cold start? Well, a machine shop near me is not necessarily going to be a good choice. And as Gary said, he's got machine shop partners all over the US, and he does this on a big time basis. Is it listed? Would that supplier be listed in ICON, the B selection, as a prior approved metal casting source? Well, if you can find one of those, that would be great. If not one of those, then one in C listed in ICON as having metal casting tooling means that they've made this casting in the past. That would be a great choice. DLA legacy components of all kinds need to be produced in the US, so located in the US is important. A machine shop having their own in-house machine shop would not, in my opinion, be a good choice because, and I hate to say this, but I think it is true in many cases, foundries that have their own machine shops sometimes use machining to basically make it easier to avoid defects, machine away defects, and essentially make the casting easier to set up, for final machining. So the reality is you need to set up these castings on as cast surfaces with the principles that Gary talked about. So it's better to use a partner. F says partners with machine shops who are separate businesses. Yes, that's a good idea. And certainly in G, machine shops who specialize in machining castings, because it is way different. And then finally, chooses, or I guess next to finally, chooses the same local mold cavity tooling builder. Again, Gary is in Montana, and all those folks you saw spread across the country choose Gary because he's got all of those solid model tools that enable him, along with the expertise, to make solid models of the 3 versions that are going to work. And then finally, choose different mold cavity builders based on their capability. Can't read that one entirely on my screen, but yes, that in effect is Gary.
All right, thanks, Mike. So Keith, we talked a lot about how machine shops could use ICON as a tool in this webinar, but it looks like we have a lot of DLA and ESA type folks on this webinar. Do you think you could talk a little bit about how they may find ICON useful?
Yes, Julia. I think, Julia, you may have my video turned off, but that's okay.
I can probably fix that for you.
Yeah, there you go. Yeah, the ICON is, as mentioned in the webinar, ICON is a fantastic tool for particularly machine shops that might be going up the learning curve about how to bid and manufacture parts that are castings. They do have help available. Actually, I could probably help you myself if needed, and I'm available through AMC. I know there are others on here that could as well, but also Sheila Rayburn for NIFS is really one of the folks that have helped develop the capabilities of ICON in the past 5 years. She's thoroughly knowledgeable. So there's lots of help available. As far as what ICON can do for someone who's seeking to bid on cast parts, you can, as the video mentioned, you can set up your business profile and kind of tailor your profile so that the ICON tool will go and search DIBs for solicitations that match your profile, send them to your inbox so that you can quickly review 5-10 solicitations daily if you want to. And as the video also demonstrated, just a few clicks, you can find out an awful lot about what that solicitation is all about. You know, what the casting is, the alloy, the casting process, the list of drawings. Now, if you've already won an award, you have access to the TDP, and you can take whatever time it is needed to review the complete TDP. But if you're an awardee and you just want to take a quick look at what the situation is so you can begin your project management thinking, Icon is a great tool.
All right, thanks, Keith. And I will attest to Sheila's helpfulness. I will put my email in at the end, and if you guys need any help getting into contact with Sheila, if you're interested in Icon, I know she'll be more than willing to help, and I can help put you in touch with her. All right, so it looks like we have a slightly more technical question, and that is kind of leading into, why did we concentrate on AirSet as a process over other sand processes? So Mike, maybe do you want to take that one?
Yeah, I'll take a shot at it, and Gary can probably chime in as well. In most cases, the AirSet process is accurate enough and has surface finish enough to meet the DLA casting requirements on the 2D basis, on the 2D drawing, and do so on a first article approval basis. However, there are times when, as just Julia showed in her wrap up of the video, where designated properties are required. And you can see in those simulations that Julia showed, as well as Gary showing the designated areas on the drawing, the AirSet process only compared to the investment casting process has the ability to control temperature gradients and the mass gradients, because the mold is cold and you can set up the geometry and the temperature gradients to achieve those designated properties. And that's why like AMS A21180 will specify those designated areas and also say, for example, it needs to be AirSet. So it does have that advantage in terms of the ability to control solidification integrity. Solidification integrity is what results in mechanical properties. You know, Gary, do you want to add anything to that? I think he's muted.
It does look like he's muted. Yep, now you're unmuted, Gary.
Okay. Yeah, I think in going along with your integrity of the casting and that is the AirSet sand also makes it very easy to place chills into the mold, which cools the metal quickly and densifies it, which gives you the higher properties. So in green sand, that's very difficult. In AirSet, it's pretty easy to ram those in there.
That's a very good point.
All right. Thanks, Gary and Mike. So we have another question, and it kind of goes into how is it possible or really prevalent that, you know, maybe a machine shop bidder doesn't realize that there's a casting in the solicitation. Mike, could you talk about that, of what leads to that happening?
Yes, and I think Keith can chime in on this one because he sees this all the time. What happens, I think, because of the short bid window, 8 to 10 days, working days, it's difficult to really dig into the TDP. And it's, you know, some of these past award prices are attractive. And if you're a machine shop thinking, gosh, I could machine that, shade that, looks like something I could do within that cost envelope. And so you wind up not fully understanding what you're getting into, not even understanding at times there's a casting embedded in that technical data package. So Keith, you want to chime in on that, because you do see this.
Yeah, Mike, I agree with what you've already said, but just amplified a little bit. This past week, got a request from someone seeking some help on a part that they were bidding on, and in this case, the top level drawing referred to another drawing as a make from. So you actually had to look 2 or 3 drawings deep before you could find out that the make from was actually a casting. So it's not a real quick thing to review these TDPs. I know some of the TDPs might have a combination of 25 or 30 drawings and specs. So it is kind of easy to miss the fact that there's a casting embedded in the TDP. So tools like Icon can simplify that. But don't be surprised if you have to look 2-3 drawings deep to find out what it's actually made from.
Keith, just to add on to that, I was just looking at one yesterday that got into it and found that make from drawing, but the make from drawing was not in the TDP. So now you got a whole nother problem to try to figure out.
Good point. We probably need to let DLA know that there's a problem with that TDP.
Okay.
Yeah, Keith, did you want to maybe just elaborate on that point, what a supplier should do if they run into a question, where there's something appears to be missing out of the TDP?
Yeah, if there's something like that that you think this might be a cast or a forged part, you can contact at Richmond AVCAT, the AVCAT, and these addresses will be in this solicitation, especially if it's a suspected casting or forging or a confirmed casting or forging. There are addresses in there for help that you can get at the Supply Center for Land and Maritime in Columbus and for aviation at Richmond. So those are important contacts, and generally you'll get a response within a day or so. And if you're also having trouble, you can contact the DLA DIBS help desk, and we can put that number out there, Julia. I think I can get it for you later. But it's also on DIBS on some of the introductory pages of DIBS. You can find the help desk for DIBS, and you can look for C folders and contact them and explain the problem. And the C folders help desk folks can stage a drawing that might be missing. And so I would recommend first contacting one of the supply centers that are addressed in the solicitation. The addresses are provided in the solicitation. And then also, if you still need help, contact the C folders and DIBS help desk.
All right. Thanks, Keith. And when I send out a follow-up email from this webinar with the recording, I'll include some helpful links. And Keith, if we can find that number, I'll put that in there too.
Sure.
But I'll include all the links that I've put in the chat as well, just as an FYI for you guys listening. All right. So it looks like I have one more question. And that is kind of going to the fact that it seems like in the past, everything was a little bit easier. If there was some sort of surface nonconformance or an inconsequential dimension, that could be waived. Why is that not the case today?
Want me to take a shot at that one, Julia?
Yes, please, Mike.
Okay. In the old days, when as I mentioned in my segment of the presentation, the original metal caster and the prime who developed the weapon system usually, and this is quite a long time ago, but they had their own in-house machine shop and they chose the metal caster. Well, there would be, with castings, there's all kinds of as cast surfaces that are very difficult to actually comply with a 2D drawing, because the 2D drawing doesn't really anticipate all those things that you saw in those images of how all the red stuff was attached to the casting and all the draft that was on all those cores that were kind of buff colored. Well, that's the reality of the way castings are made. So back in those days, the metal casting source would contact engineering at the prime and say, hey, we have a dimension here that's out just a little bit. And the example that I showed was off by 10 thousandths in a machine stock that was 156 thousandths wide. So the engineer would say, oh yeah, that's not a problem. It'll just machine away, so don't worry about it. But he gave approval, and I've had this happen in the commercial realm myself, where I'd say, we need to change this. And the commercial, like in this case, it might be Peterbilt or Kenworth truck manufacturer, say, yeah, okay, you can do that. But they would never change the drawing. So you fast forward 30, 40 years, and the drawing was never changed. And now a casting which has the same potential nonconformances has to comply with the 2D print, because the engineering authority at the base responsible for that system really has no way of knowing what that original thinking was. So, in support of the engineering support activity, you really have to agree with them unless they want to take an aircraft that's out on the line somewhere and open it up and stick this part in there to make sure that it doesn't cause a problem in assembly or function. The answer is always going to be just make it like the 2D drawing. And that makes it really, really difficult for these cold start new awardees, whether they be a machine shop or whether they be a metal caster. It's tough. And that's what these 2021 and 2022 webinars are all about. It's basically saying, if you've won an award these days, you need to be really, really careful. And this series in 2022 is, hey, think this stuff through on a project management basis from the very, very beginning, and you'll save yourself a lot of grief.
If you don't, you can go upside down real quick.
Yep, and you're the one that picks up the pieces when they do, Gary.
I'm the one that goes upside down sometimes.
Not much.
All right. Thanks, Mike. Thanks, Gary. So it looks like that is all of our questions. So I'm going to put the link to the survey for this webinar. Please fill it out. It really helps us see what type of topics you guys want covered and whether this was helpful to you or not. We really do use your feedback as we develop additional webinars. But I do want to just thank everyone for participating today. We are going to hold part 3 in October and then part 4, which is the final part of this series, in November. I'll send out the date to you guys in an email. Additionally, I will send up a follow-up email, like I mentioned, with all the useful links and information, as well as the link to the video recording of this. Once again, just please take a moment and fill out the survey. And if you have any questions, feel free to reach out to me. One last thing, if you are attending this for a CLP credit, please send me an email and I can send